Good evening, students. In this video, I am going to explain about estimation of missing rainfall data. The record at many rain gauge stations may consist of short breaks due to several reasons, such as the absence of the observer, instrumental failures, etc. In such cases, it might be needed to estimate the missing rainfall amount by approximating the value from the data of the nearby rain gauge stations. The following methods are generally adopted for computing missing rainfall data. The first one is interpolation from isohydral maps, second is arithmetic average method, and the third is normal ratio method. In the first one, interpolation from isohydral maps, missing precipitation records may be interpolated from the isohydral maps, which cover the period in question. Skillfully drawn map takes local rainfall characteristics into account, including the average patterns, distance from the sea, topography, and storm paths. Interpolation of missing data from such maps will be reasonably accurate. Second is arithmetic average method. If the normal annual precipitations at the adjacent stations are within 10% of the normal rainfall of the station under consideration, then the missing rainfall data may be estimated as a simple arithmetic average of the rainfalls at the adjacent gauges. Thus, if the missing precipitation at station X is Px and P1, P2 and Pn are the rainfalls at the n surrounding stations, then Px is equal to P1 plus P2 plus P3 plus Pn whole divided by n. And the next is normal ratio method. If the normal annual rainfalls at the surrounding gauges differ from the normal annual rainfall of the station in question by more than 10%, the normal ratio method is preferred. In this method, the rainfall values at the surrounding stations are weighed by the ratio of the normal annual rainfalls. You can see the formula on the screen, and we can calculate or estimate the missing rainfall data with the help of this formula. So in the next video, I'll explain about design of rain gauge networks. Okay guys, I'll continue the design of rain gauge network also. I'll cover now. Design of rain gauge network. Rainfall records constitute the most important and fundamental data required for hydrological investigations. They are required for analyzing storms, fixing design flood, forecasting floods in river, reservoir regulation, etc. For all such studies and investigations, A well distributed network of rain gauge stations within the catchment is essential. To obtain reliable results, the various rain gauges should be evenly and uniformly distributed within a given catchment. Moreover, the total number of rain gauges installed within a given catchment area should neither be too many as to be costly nor should be too less as to give unreliable results. A network should be planned to yield a representative picture of the areal distribution of rainfall. Hence, there should be no concentration of gauges in heavy rainfall areas at the cost of dry areas or vice versa. The minimum rain gauge density required for different types of catchments as per the guidelines of World Meteorological Organizations are: first one is for flat regions, second is for mountain regions, third is for arid or polar zones. For flat regions, first one for flat regions of temperate Mediterranean and tropical zones. One station per 600 to 900 square kilometers for developed and developing countries. One station per 600 to 3000 square kilometers for countries with limited funds, population, communication. Second one, for mountain regions of temperate Mediterranean and tropical zones, one station per 100 to 130 square kilometers for developed and developing countries, one station per 250 to 1000 square kilometers for countries with limited funds, population, communication. Third one, for arid or polar zones, one station per 1500 to 10,000 square kilometers. In India, the standard prescribed by a high level committee on floods set up by the Government of India recommends to establish minimum one station per 518 square kilometers. This is how we can fix the rain gauge stations. Thank you. And in the next session, I am going to explain about the optimum number of rain gauges, hydrograph, mass curve of rainfall, etc.